The arc that a basketball makes when thrown for a basket is a parabola. Orbits of the planets are elliptical. Cooling towers of nuclear reactors are hyperbolic in shape. All three are examples of conic section. Why are they conic sections though? What relation do these shapes have with a cone? Conic section implies that they are formed through a cone. If that is so, how are they formed through a cone? Let's see how in this video. Our objectives are to learn the concept of conic sections, to form a right circular double-naped cone. We are familiar with the geometrical shapes such as lines, polygons and circles. Let us observe what happens when two planes intersect. We see that a line is formed. If a plane intersects a hollow quadrilateral prism, a quadrilateral is formed. When a plane parallel to the base of a cylinder intersects or cuts the hollow cylinder, a circle is formed. We know that the planets revolve around the Sun in stretched circular paths. To understand the formation of such curves, let us proceed with an activity. Let us have two intersecting lines with a point of intersection V and the angle between them alpha. Rotate the line M in such a way that the angle alpha remains constant. The shape generated is a double-naped right circular cone. The line is the axis of the cone and the rotating line M is called the generator of the cone. The point V is the vertex. The angle alpha is known as the semi-vertical angle of the cone. Let us observe the shapes we get when the plane intersects the double-naped cone. Let the plane be inclined to the axis of the cone at an angle theta. When the plane cuts the cone at right angles to its axis, that is theta, is equal to pi by 2, a circle is formed. Now, let the plane cut the cone at an angle greater than alpha and less than 90 degrees to the axis. That is, pi by 2 is greater than theta is greater than alpha. The curve formed is called an ellipse. When the angle between the plane and axis is equal to alpha, that is, theta is equal to alpha, a shape called parabola is formed. Here, we can observe that the plane is parallel to the generator of the cone. Since parallels never meet, the plane never cuts the other part of the cone. When the plane cuts the cone at an angle less than alpha, that is, theta is less than alpha, a hyperbola is formed. Thus, we observe that different shapes are formed when a plane intersects a double-naped cone at different angles. To summarize, in this video, we have understood the concept of double-naped cone and also the curves formed by the intersection of a plane with a double-naped cone. The curves formed are the circle, the ellipse, the parabola and the hyperbola. These curves form the conic section. Now we know how to make different conics from a double-naped cone. Is that the only method to construct conics? Or are there other methods to construct conics? What are the properties of different conics? Watch the next videos to get answers to all these by learning more about conics.
Keep imbibing. We believe in you.